Okay, we are doing section 7.4, which is solving linear systems by multiplying first. This is very similar to section 3, which was elimination. This is still going to be using elimination. The only difference is they're not going to easily cancel. We'd have to multiply by something first. So we still want to end up canceling one of the variables. So what you're going to look for is one of the variables that have opposite signs. That's the first thing you're looking for. So right now that's our y terms. And then what you want to do is you want to make sure that you can get them to be the same number. So if I want those to be the same number but opposite signs, I would need to multiply the top function by 2 because then it'll have a 4y. So that's going to be 10x plus 4y equals 32. And then everything is going to cancel. We add down as normal, 13x equals 52, divide by 13, and x equals 4. And then what you can do is substitute that x equals 4 back into any equation that you want to. I usually go back to one of the original equations because I don't want to deal with bigger numbers than I have to. So if I put that back in the top one, that's 20 plus 2y equals 16. 2y equals negative 4. Y equals negative 2. So our answer is 4, negative 2. So if I were to rearrange and graph those two equations, they would intersect at the point 4, negative 2. Okay, so we're going to do the same thing. We're going to try to figure out how to make the signs opposite in one of our variables and the same number so that they cancel when we add. So I don't want to have to multiply by both equations if I don't have to. So I am looking for a number I can multiply to one equation so that one of our variables will have the same number. Now if I multiply the bottom equation by negative 3, then it's going to have a negative 6x and it will cancel with our positive 6x. So I'm going to rewrite the whole thing. Okay, once I do that, I can add everything down. And we have negative 4y equals 4, and y equals negative 1. Then, like last time, we're going to plug that negative 1 into any equation that we want to. I'm looking at the first bottom one. 2x plus 3 times negative 1 equals 5. 2x equals 8. X equals 4. So our intersection point would be 4, negative 1. Okay, so like I said, you're going to try to look for something you can multiply to one equation to make one of the variables cancel, but it's not always going to be quite as easy as that. Sometimes you're going to have to multiply both. So in this case, we don't have any opposite signs yet, so we're going to have to multiply one of our equations by a negative number for sure, but we're looking for one of our variables to cancel. To me, it looks like the easiest thing to do is to cancel the x's. If I multiply the top one by 7, the bottom one by negative 2, then both of our x's will have 14s. Only one of them will be an opposite sign, and we will get those to cancel. So 14x minus 63y equals 7, and negative 14x plus 24y equals negative 46. At that point, I can add everything down and cancel. Negative 63 plus 24 is negative 39y. And negative 46 plus 7 is also negative 39. So when I divide, my y is just 1. And then I'm going to substitute that y into my top original. So my point is 5, 1. Okay, so this is called multiplying both and subtracting, but we are actually going to just continue to add. Remember, the book had the process of subtracting, but I want to keep it consistent, so we're always going to use the adding method. So before I can multiply anything, I need to rearrange. So I would subtract the 3x which gets rid of that one so that I get all my variables to line up. And then I can look at it and see what I need to multiply by. Well, since the x's are already opposite signs, that's the one that I want to cancel. So if I multiply the top one by 3 and the bottom one by 4, I will get the x's to cancel. So we have 12x plus 15y equals 105. Negative 12x plus 8y equals negative 36. Add down, 23y equals 69, and y equals 3. Then I take that y equals 3 and plug it in anywhere that I want to. I want to plug that into the top original. So my point is 5, 3. Okay, here's 3 sets. I'm going to multiply the top one, no, bottom, sorry, by 3 and rewrite. Then I'm going to put that in my original bottom. So obviously you can end up with fractions sometimes. So if you start with have a fraction for your answer, don't think that you got it wrong. You might not have. On B, I'm going to multiply the top one by negative 2 to make my y's cancel. So it'll be negative 4x minus 10y equals negative 6. This is negative x equals negative 9, so x equals 9. And then I'm going to put that 9 into the top original. The answer is 9, negative 3. Remember, if you're unsure about an answer, you can always plug the x and y that you get for your answer back into both originals to see if they work. That way you always know if you have the correct answer. C needs to be rearranged. And if I multiply the top by 5 and the bottom by 3, I'll get the x's to cancel. That is negative 8y. So y is negative 5. And then I put the negative 5 back into probably the top original. So negative 10, negative 5 is our answer on that. Okay, our word problems. Darlene is making a quilt with alternating strips of regular quilting fabric and sateen. She spends $76 total on 16 yards of both. Find a system that can be used to find the amount of each she purchased. So the first thing before we start this problem is I need to label how much everything is costs for the quilting fabric and the sateen. Quilting, this would be included in your problem. I just forgot it. Quilting is $4 a yard, and sateen is $6 a yard. So it's telling us that X is quilting and Y is sateen. So we're going to have two equations. Our first equation is going to be just our yards of each and our total. So we don't know how many regular, we don't know how many sateen, but we know that there's 16 total. And our other one is going to be the cost. So 4x plus 6y equals 76 for our other equation. That's all we had to do is set them up on this top one. This bottom one. Sports equipment stores having a sale on soccer balls. One coach purchases 10 soccer balls and 2 soccer ball bags for $155. So before we continue, that's our first equation. And then another soccer coach purchases 12 soccer balls, so that's 12x, and 3 soccer ball bags, that's 3y, that's equal to 189. Find the cost of a soccer ball and the cost of a soccer ball bag. So we want to cancel, using the elimination method, one of our variables to solve this. And it looks like the 2 and the 3 are going to be easier to manipulate, so I'm going to multiply the top one by -3 and the bottom one just by 2. So that's negative 30x minus 6y equals 155 times -3, which is negative 465. The bottom one is 24x plus 6y equals 189 times 2, which is 378. Add down, this is negative 6x equals negative 465 plus 378, which is negative 87. So negative 87 divided by negative 6 is 14.5, so that means $14.50. X represents the cost of a ball, so this is per ball, and then we plug that 14.50 into X. I'm going to go with the top equation. So this is 145 plus 2y equals 155. 2y equals 10. Y is $5, and that's per egg. Here's our answer. Okay, that was section 4 on using elimination, including multiplying before you do the process.